Okay,
because
so
we are usually more discussion oriented.
if you can help us to take some notes, that would be amazing, because we were planning to turn this into a blog post after the conference.
Okay, I'll figure out the Wi-Fi situation out there.
So I guess we can kind of start. First of all, and folks, I stole your slide templates. Thanks. Those are very, very beautiful. I am Fabiano Fidêncio. I work for NVIDIA. Together with me here, we have...
I'm Cameron. I work for Northlink. So Northlink is basically an app platform for Kubernetes. We run 2 million containers a month. We offer multi-tenancy as a solution, so we need somewhere to run secure code and some way to run it. So we rely on Kata Containers and gvisor to basically provide that for our customers.
And knowing that this is not being recorded, he fired me. Jokes aside, we proposed this, but we actually want to have a conversation. It's more like having a conversation than anything else, and that's the reason we have a bunch of Kata Containers contributors, AC members, very good people who were in the project for like 7-8 years, and that made me stay in this project so far for 6 years. So we are gonna get them here quite soon. But yeah, what we are gonna talk about is, so in the experience that I had at Northlink, we are trying to run Kata Containers on bare metal. Like Kata Containers on bare metal, great, it works. When you go and try to run Kata Containers on CSPs, then we have some problems. And we're going to try to have the conversation here by addressing those problems that are commonly encountered. And please don't take me wrong, we are not doing any kind of backlash in the community. We love this community. We are part of this community. And we are here to improve and try to improve as much as possible, as we have been doing the past 6 years or so. Then we want to have a bunch of discussions. I'm not the person to answer the majority of the questions here. We have way more capable people here. And also, all the questions that we're going to bring maybe are not all the ones that you guys have. So we are welcoming you to also raise your questions, and we are here to try to reply. With that, we should come up with some plans for the short-term future, what we want to achieve. And of course, takeaways are going to be as in a blog post. So, next slide, please.
Absolutely.
Okay, so what are the common challenges, right? So if we try to run Kata Containers, well, Kata Containers, is everyone here familiar with Kata Containers? Is someone here who is not familiar with Kata Containers? Okay, cool. You who are not familiar with Kata Containers, are you familiar with containers? Yeah. Okay, cool. Containers, they provide you this nice isolation via C groups, via namespaces, you know, some mandatory access control, you know, as a Linux, and then you can just run your code there. With Kata Containers, we have pretty much the same thing, but we add an extra layer of protection, which is the PVM layer. So you are running your workload inside a very lightweight virtual machine, and this is great for multi-tenancy, because if there is escape, you are not on the host. You are inside the virtual machine, which is very stripped down, and there is not much you can do there. So that's the concept. It was created in order to run, for the platform owner to run untrusted workloads. Not all workloads need that, we know, but if you have the need for something like that, Kata Containers may be a very good solution for you. Okay, so this is Kata Containers in a nutshell. But as I mentioned, you have this very thin KVM layer around your container, which means that you really need virtualization access. And when you are trying to run Kata Container on CSPs, it gets a little bit tricky, because if you think about, let's say, Google Cloud. Google Cloud gives you virtual machines which have support for nested, only on Intel. Sometimes the performance may or may not be what you are expecting. Azure provides you support for nested on Intel and AMD, so you can do a better comparison there. But if you go to let's say Amazon, AWS, which is one of the most used providers, unless you are really willing to spend a lot of money in a bare metal, you cannot run Kata containers there. They do not provide any kind of access to necessary virtualization. This, in general, is a huge problem. And here is the part where I would like to start the conversation with the community, because we have some very bright engineers here who have been working on potential solutions for this. How we take out the necessary virtualization needed from Kata containers. Of course, there are other projects that can do that. If you think about Divisor is a way to do that. It's not that lift and shift. There are good and bad things about Divisor as well. The approach is different. But right now, what I would like to ask Fupan, Shu, come here.
Oh.
And Marcos.
Yes.
So the community has been working on basically two solutions for that. One is called PVM, which you should be able to avoid nested with that, and those guys have came up with very bright patches about that. They're going to explain these a little bit more. And also we have something that's called peer pods, which Marcus is going to be the one talking about. And just to make sure, we didn't rehearse this very much, so it's going to be as it's going to be. So if you guys can talk a little bit about the PVM solution.
Okay. The PVM solution is used to replace the PVM. You know, the PVM is based on the Intel AMD's the hardware virtualization solutions. But for some cloud provided the machines such as the Alibaba Cloud and other cloud, they didn't support the next version. So we want to run Kata containers anywhere in the cloud. If they not supported the hardware virtualizations, we even want to run the Kata containers out there. So we invented a new virtualization we call the PVM. PVM we call it pair-virtualized page-based virtualization. Yeah, it only uses the hardware's page virtualization to virtualize the entire machines. So the PVM has been open sourced in the kernel repository, but it hasn't been accepted by now. And I think this will take a long time to merge into the kernel, but I think we want to try our best to improve it.
Yeah, let me give more explanation about that. Yeah, actually, we, from the beginning of Zen project, it's used something like pair virtualization. Yeah, but most modern virtualization VMM is based on PVM. So, but from the kernel 2.6. I think 23 or 25, the so-called PVOps has been introduced into the kernel mainline, and for the Zen support, and so we can use this extension for KVM. That may we can introduce a driver for KVM just like the x86 driver. So it just use the page table things, or say we may use the shadow page table, and for the virtualization, and we don't need the VT, and yeah, because you know the VT is provided by the hardware, and some of the cloud providers such as I think the Azure and the GCP provide the embedded virtualization, so you can have the VT in the virtual machine, in the instances. But for EC2, the AWS EC2, you don't have, because some cloud providers just say it's the embedded virtualization is not safe enough. Yeah. And maybe that's true, and maybe that's for some business strategy. So in that case, you don't have embedded virtualization. And as a test, for some memory-intensive usage, the embedded virtualization performance is really bad. Yeah. And in general case, in about I think 5 years ago, the embedded virtualization have about 1/4 of the hardware of the not embedded virtualization's performance. Right now, the embedded virtualization has been improved.
A lot.
Yeah, a lot. But still, many hardware, that depends on new hardware.
Exactly.
Yeah, and some cloud provider don't have that. And yeah, so if we introduce the page table based virtualization, yeah, we can have a usable performance that's much better than the embed for almost all the hardwires, and for especially you can use that for EC2 and other cloud providers that don't have the embedded virtualization. So this is a easy way to provide the container cloud based on any cloud. And this means, especially means for some, we ran a startup years ago to provide the container cloud, that's based on bare metal. But right now you can use that without a bare metal. That's much easier for you. And especially if you provide something like function or something, the fast start and fast stop ones, maybe you can use something like the spot instance that may reduce your cost. Yeah, and yeah, that's all. And actually, if 2 years ago, I think this could be used something like a developer tools, just because many people use the EC2 instance for their development. Yeah, but right now, many people want to set up agent sandbox for
Yes.
that. Yeah, that make the topics even much hotter than before. Yeah, interesting. Yeah. That's about the PVM. Another thing is about PVM is about, because it's used PVOps that already in the kernel. That's the patch set is pretty small actually. It's just introduce a small switcher and another as a driver for the PVM, and yeah, that's still not merged by the mainline kernel, because yeah, that's somehow ridiculous, because you don't have too much, so you don't have many production usage, so the kernel community think that's not mature, and so because that's not in the mainline kernel, so the industry think that's not mature, so they don't put them into production.
It's a chicken egg problem, right? Because it's not mature because people are not using. People are not using because it's not there. So
yeah, but there's still some stuff use that, and also we are using that our production already. Yeah, because we have some, we have our private infrastructure. We upgroup it and a fintech company, and we have several clusters with more than 10,000 nodes, and that's all bare metals. But still, for the cost part, we still use some cloud instances to reduce our cost for the heap of the business.
let me ask one thing. We are talking about kernel patches that are not being accepted, right? Those kernel patches, we are talking about kernel patches on the host, on the guest, or on both sides.
Yeah, actually, you think about the power virtualization. There must have some part on the host, yeah, and some part at the guest, and
And
not
this-
so big, but that exists.
And this is the part that we would like to see being pushed forward. If someone has contacts on the kernel community that can help us to push this forward.
Yeah.
Because while this is not part of the host kernels, those patches are never going to be on CSPs. If those patches are not on CSPs, we still have to deal with nested everywhere, and we still have to pay a lot of money for those EC2 instances from AWS, which is not exactly something that. Let me shift a little bit. There was another solution that was introduced by the community, it's called peer pods. Marcus has experimented with peer pods quite a lot, and you can tell us a little bit about what peer pods is and the drawbacks that you face it.
Yeah, so hi, I'm Marcus. I'm with Edgeless, and we're actually running Kata Containers in production. I spent the better part of end of last year trying to get peer pods running, and at the end of the day I failed. And maybe I can share a bit about what I encountered. I want to draw something.
Do we have shock?
Yes, I just saw it.
Yeah.
Thanks. So maybe a quick recap of how Kata works overall. Like you have, let's say we have a bare metal node. We have a bare metal node. There's a kubelet running here. The kubelet's talking to a container D. Let's say cryo because it's shorter. The Kata runtime is actually registered at the CRI implementation, so in this case cryo. So cryo starts a Kata process, which is like the shim. The shim then goes and starts a VM. Inside the VM there's an agent. And that agent spawns your containers. There is communication between the kubelet occasionally talks to cryo. Cryo regularly talks to the shim because it needs to observe what the container is doing. It's calling these container status methods and so on. And so we have a connection here. This is in a standard bare metal situation is a VSOC connection, and there's a TT-RPC communication going over here. Okay, nobody can read this anymore. So what happens if we want to run peer pods? So the idea of peer pods is you have this setup somewhere. Does not matter if it's also in the cloud. I'm drawing it outside the cloud for now because that drives the point home more clearly, I think. So we do have a cloud here. The idea of peer pods is you get rid of all of the stuff that's running here because you want to run in the cloud, and you maybe cannot even because you are actually in a VM yourself here. So the idea is get rid of all the things here. And instead run the CAA. That's the Cloud API adapter. So here's the connection via VSOC. This Cloud API adapter does two things. First, it calls the Cloud API to get some machines. So we want to run a container here. Now I need to get a VM at the CSP. So the CAA first goes, creates a machine. When the machine is ready, it will be a VM. Inside the VM, you'll have an agent again. But what you also have is a reverse proxy. Because remember, the shim wants to talk to the agent, and the CAA is designed to actually not make the shim aware too much of that this is going on in a totally separate location. So what it actually does is, there's a VSOC communication here, the CAA goes and has a gRPC connection, I think, to here. And this is again a local socket. There are a couple of things that this works, right? You can deploy that. There's instructions on the internet, on the confidential container side, or also like probably in the Kata doco, where you can just figure out how to make this work. You can spawn VMs, and that will work. What will not work, however, is things like CSI. So CSI is designed mostly for node local operations, right? So in CSI you have these cluster-wide components, and you have the node local components, and the node local components need to somehow like get volumes to that thing here. However, that thing here does not know what to do with these volumes. On the other hand, we here have volumes, but these are like the cloud provider volumes. Whatever. That just does not fit together. So there are a couple of hacks in CAA that kind of make it work so that you can have storage on your VM, but it is not integrated whatsoever with your CSI. And you need to be very aware of all of that happening. Next thing that does not work. Remember, here's a TTR-PC socket over a VSOC. VSOC is a stable connection, right? Nobody will screw up with your VSOC. However, that connection is not stable. There's a bunch of requests, as I said. Cryo is talking a lot to the shim is talking a lot to the agent. If a single request of these fails, the entire TTR-PC connection breaks down, because TTR-PC is designed for reliable sockets. So what happens is you lose the connection here once. That fails a connection, or that fails a request here. Then Cryo says, oh, this container is obviously done. Let's just kill everything here. And then everything here is killed, and this VM keeps idling.
And you are paying for that.
You're paying for that. I appreciate that. The next thing is, and this is why I also do it with the cloud here and on-prem or something here, is what's with container networking, right? So you have your E0 here. How does that, like, and this is, I don't know, you're running Cilium or like a nested CNI with, what's it called, Kilo or something. There's a lot of sophistication happening on this thing here. How does it actually connect to that VM here? I think what's supported right now, and I hope like if anybody has more experience with CAA than I do, please like correct me. The last time I checked, this was kind of implemented for not inter-cloud, but only intra-cloud operations. So you needed to deploy your CAA or this entire thing in the same cloud, in the same virtual network, so that you can actually, via backdoor or something, you have a configuration for the CAA that says, please start these VMs inside this virtual network and give it a Kubernetes-like E0.
If you use Milvus or something.
Yes, and this also breaks down. Like it's just not designed, and it can also like not really support the assumptions that go into CSI, into CNI, and you need to work around all of that.
So yeah, we have a quite complex situation here that could be easily solved by some kernel patches being reviewed and merged, as you can see. This is still something that folks have been working on, trying to improve. It solves some of the situations. It does not do lift and shift in the best way possible for you. It depends a lot on your use case, but this you can use today. The work that Anti-Group has been doing is amazing. We just need to get the right people to review it. And we have been looking forward to that. So again, if you have community members, friends who happen to be kernel maintainers, please, you really need some help here. I'm gonna just pass the mic to Cameron. There are other topics that we could explore a little more about nested virtualization, but we are gonna do this in the corridor because time is limited. So, but yeah, Cameron.
Yeah, sure. So actually something that Marcus said is also applicable as well for just running directly on CSPs without the whole sort of separated setup, and that's container storage interface. So so basically CSI works by you request a volume, by default you have a file system PVC, that gets mounted to the host, great, like works perfectly for runC, but the issue there is that gap starts to get larger when you're running the Kata containers because you've got that difference in basically host and guest. Now, that's solved by basically virtualFS at the moment, but with AI sort of becoming bigger and requiring more storage performance, virtuFS starts to sort of fall over at, when you start to really push it. So one of the solutions that you can sort of get around this is virtuablock or virtuascsi. But there exists a gap basically between those CSI driver implementations and basically mounting a block volume. Now you can do it basically with a PVC. You can say I want a PVC with volume mode block, but then you start to lose some of the sort of file system operations that you get by default through the CSI driver. So that's volume formatting, volume resizing, auto expanding volumes, that kind of stuff. All of that management has to be shifted to you. That then, you may need to think about, okay, I need an init container that needs privilege, I need to run my workloads privilege because I need to do the mount, and sort of you start to break down that security boundary more. So there's something that we've been looking at Northflank. So we run all types of workloads, stateful, stateless, and we want to make sure that we've got the best performance possible. So we started to explore basically how we can sort of implement this and also make it so it works between different runtimes, because what works for Kata is potentially insecure in run C, is potentially insecure in gvisor. So we've started to look at maybe how we can use NRI to plug in and do that formatting, do the mounting for us, or hand off the mounting to Kata Containers. And I think as well, a couple of years ago there was a sort of a request for comments on the Kubernetes side, which was basically to allow the CSI drivers to do mount handoff to basically the runtime. And I believe the folks at Alibaba may have implemented that in their CSI driver.
For fun, maybe you know a little bit about that?
The CSI?
Yeah, the direct block device handoff.
Direct volume?
Yeah, that's the one.
Alex?
Alex, you're here!
CSI?
I'm loving this talk. I have all these smart people actually talking. It's amazing.
Direct volume CSI.
Okay, Lori, let me see. CSI is a CSI direct volume. It's dedicated for Kata runtime, and the backend is just a profile or raw disk, and we will generate its responding information like the device path and its system and its a file system. Especially we default support the EFT4, and its responding its corresponding attributes, and we will generate the multi-info.json file and located at the fixed parse under the run Kata containers shared direct volumes, and when the Kata runtime running, and it will search the parse and then match the target file and the parsed, and Kata runtime will generate the each container mount information from the JSON file, and then parse it to Kata agent, and next it will be inject to container OCI spec, and then the mounting will be the file backend on the host will be inserted the VMM, and then mount it into the container, or bind mount into the container with its destination. That's it.
I have one question, if you don't mind.
Yeah, go for it.
How does it work with different providers, right? You have to have your own CSI driver from different cloud providers where you can have then that be translated to a common layer. How does that?
I think it's inconvenient. So and by now they support the file and the block device and the hardware block device, and we use the web versions and also some device mappers blocks. Yeah, I think it's independent from the pointers. Yeah.
Nice.
But you would actually need to build a proper CSI driver chaining or something, right? So because like, or what I understood is that the direct volume is some more bypass of the original designs, right? So because it's feeding information to the Kata agent via a side channel, right?
Yeah, yeah.
And like if you can couple this with like generic CSI drivers that are available from cloud providers, that might actually be a way to go. At least for bare metal, that still does not solve the cloud problem.
No, those are different problems. Yes.
Yeah, I don't believe there's many CSI drivers that have implemented this, is there? I think it's just the Alibaba folk.
I think CSI, direct volume CSI, originate from Alibaba and group. Also, say internally, our internal work uses such feature, direct volume. Yeah, we have support such feature online and with our business work.
We have folks from Microsoft working on this as well.
Okay.
Aurelian from Microsoft. So Microsoft is heavily relying on Kata Containers as well for some of their use cases. And we have a very nice architecture committee member called Aurelian Bombo, and he's also trying to push this forward on the Microsoft side. So that gives us some hope that like more and more CSPs can end up adopting that, which is one of the problems that we have.
But it will still be a while away then.
It's still gonna be a while, yes.
Yeah, I think the last thing really that I wanted to bring up, I think I hope we've got enough time, is basically around sort of startup speed and basically performance. We're starting to see that you know, we have more competition in like the ECS space and the fly.ia space, where they have containers starting up in less than a second. Obviously, most of these are not dealing with Kubernetes, which has its own sort of latency. But ideally, we want to try and bring down and trim off latency wherever possible, so that we can start containers incredibly fast. I don't know if any of you folks have been working along sort of those lines, trying to bring that startup speed down. And it's alright to say.
I see you coming down. Amazing.
For the start speed.
Yeah.
Actually, we already have some code in the Kata containers. Actually, we call it template, and actually it's based on the live migration. That means you migrate one virtual machine to the same host, so you don't need to copy the memory at all. So we firstly create a template. That's a dumb virtual machine. You don't need that. So you just write some code in your agent, because the agent here is controlled by you, and without your command it won't start any containers. So when they start, it paused here, and then you can just pause it as a template. And when you need a new sandbox, you just do a live migration to the same host, and without copy any memory, and make it like some copy and write. So this is no time, and then you can add or remove, maybe only add the CPUs and the memories for that for your configuration. You need some time for the hot plug, and then you can inject your new spec and start the virtual machines. One thing is you need to pull the image, right? So we introduce something lazy load things. It includes some metadata here. So you can only put the metadata here and tell the virtual machine we have already have the image, and here is the file system, and you can see the whole directory tree here, but no content put here, and it will be put asynchronous, and so when the machine is access the image, it will be put here, or maybe you can pre-put something you think that's important, or maybe based on the previous behavior, you know some parties should be used, and also you know some large image, some part won't be used at all. So maybe if you can just put them synchronously later. Yeah. So that's the acceleration part, and for our colleagues from the Alibaba cloud, they use these things for their function service, and they put the function code with this way. Yeah. So they can reach a very high code start time.
I have one question for you, Shu.
Yeah.
The templating, at first it was implemented only when using QEMU as the VMM.
Uh-huh.
Right, runtime, the rest of runtime, Dragon Ball also supports this.
It's on the way. It's
Yeah,
on the way.
yeah,
It's on the way.
Yeah, we are developing.
Okay.
yeah, and in theoretically, think this is not a problem.
Nice.
It should be good.
Am I right in saying that VM templating doesn't support virtualFS as well?
Uh-huh.
Am I right in saying that VM templating doesn't support virtualFS?
So
It does not.
Yeah. Should.
Why not?
I think it's because it's copying memory. VirtualFS needs shared memory, which is not mergeable.
I have a feeling they might have fixed that.
Oh, really?
So from the Nova side, when we were looking at the virtualFS into the VM, we didn't like it until the kernel bugs were fixed so we could do the live migration. I have a feeling the live migration code might have run it now, so it might be worth looking at that again.
Oh,
Yeah,
that's
yeah.
nice.
Yeah.
I have to bear that in mind then. Yeah. Thank you.
Because I was going to say it would be really nice if the kernel cache would be shared on the host and you do virtualFS into your VM so you don't have to copy it all, right? But that would explain why that didn't happen.
Okay.
I really like the standby VM trick, right? That we keep just with VMs and can
Yes.
But-
Actually, yeah. You may want to pause it later. Yeah, but the later they may introduce something new. Yeah, it's the operating system doesn't think it will be copied as a template. So the earlier the safety.
Yeah, the point where I want to get to is like we're using confidential VMs, and with confidential VMs,
Nah,
This is not for confidential, yeah.
You know, I just talked with my colleagues work on the confidential part. Yeah, the confidential is slow. Slow is the feature of confidential. So you are a VIP for the confidential. So you should enjoy your feature that is slow. Yeah. So if it's fast, yeah, you're not the VIP.
I think we are pretty much on time here. I would like to say a big thanks to everyone who joined it. We will be around here. We are very easy to find. I'm not small, I have a t-shirt full of cats. So you can find us in the corridors. I would like to say a big thanks not only to the folks who are here, Marcos, Shu, Cameron, Fupan, Alex, Isvonko is over here, who is doing also like an amazing work at NVIDIA.
Work for the VIPs.
Yeah.
They are doing the work, I'm just delegating, so.
I wish that was not true. But no, he's doing a lot of work as well. So let's give a good round of applause to the folks that are doing. Also, our community manager is here. So, Yodiko, thanks a lot for having us here. And we will be here, like, unless someone kicks us out, like, we can be here and have a chat. I forgot about the Roshin! Sorry. Roshin is also here, a technical community member, doing risk-fight stuff. This is one of the future of the, in my opinion. So, yeah, we are pushing forward that direction as well.
And we have the Kata Containers presence in the open source pavilion from 2:10 today, so it could be a meeting point if people want to continue this conversation.
Sure thing. Thanks. Folks, thanks a lot.
Good job.